So we got two categories. Why did you do that? Oof. It just won't stay where I tell it to stay. Okay, got two categories we have to worry about. Ionic and molecular. Ionic is metals and nonmetals and polyatomic ions. Molecular, nonmetals, and hydrogen. Just nonmetals or nonmetals and hydrogen. Okay, so the molecular ones are the easy ones, okay, because their name has prefixes. And their formula just uses those prefixes. But the hard part is first you have to decide what kind it is. The mistake people make is they want to do molecular stuff for things that aren't molecular. If it's got a metal in it, you can't have a prefix. Okay? It's got a metal, you don't have prefixes? So, for example, on today's bell work, dihydrogen monoxide. If I wanted to turn that into a formula, then I would have to put, it says dihydrogen, that's two hydrogens, monoxide, one oxygen. Just do what it says. So if it's got prefixes, do what the prefixes say.
What is again the prefix for 4, 6, 7, 8?
Okay, the prefixes are mono for 1, di for 2, tri for 3, tetra for 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. Deca 10. Okay, but if I have something like C2H6, you recognize that is made of carbon, a nonmetal, and hydrogen. And I'd want to say 2 carbons and 6 hydrogens. So that would be 2 carbons is dicarbon. We leave the first word alone. Second word, hydrogen, except I changed the ending, and I want to say there's 6 of them, so that is hexahydride. I changed the ending to IDE. So that would be dicarbon hexahydride. So once you've decided it's molecular, then it's pretty easy to do. The important decision is to decide it's molecular first. Okay? Because if it's not molecular, you don't get to use prefixes. Now, ionics are a little bit more complicated. The real rule is name the ions. That's all you do. You name the ions. Except you've got 3 kinds of ions. You've got the group A ions, and we know charge, we know their charge. We know what charge they're going to make. And then we have the transition metals. We don't know their charge because there's more than one. Iron sometimes loses 2 electrons, iron sometimes loses 3. We have to say which one of those it is. Okay? So those, if it's a transition metal, we use Roman numerals. So we got the group A's, we got the transitions, and we got polyatomics. And you'll know it's polyatomic when it has more than 2 atoms, more than 2 types. If you got 3 types of atoms, the only way you know how to write the name is if it's got a group of atoms that stays together. It's all familiar stuff. Okay. So back to that ionic, you write positive first, positive ion name, negative ion name. 2 words. So if I have something like K2O, first I have to recognize that K is a metal. It's on the left-hand side of the zigzag line, not touching the zigzag line. Okay? And K, have to decide, does it need Roman numerals? Nope, because it's in group 1A, we know it's always going to lose 1 electron, so we can just write potassium. The second ion is O. We change the ending of the second ion to IDE, so it's potassium oxide. We don't write the 2 because it's easy to figure out. Because I give you potassium oxide, you're going to say K is in the 1 plus column, O is in the 2 minus column. When I do the crisscross, I get K2O1 or just K2O. Since it's easy to figure out the charge, it doesn't need Roman numerals. But if I give you MnO2, okay, I find Mn on the periodic table. It's on the left of the zigzag line, so it's ionic. But I don't know its charge, so I'm going to write its name, manganese. I'm going to leave room for a Roman numeral. And the second word, since it's oxygen, it's still oxide. I change the ending of the second word. What I need to put in there is what the charge is on manganese. That number up here goes down there. Remember, positives and negatives have to equal each other. So I know oxygen is going to make a 2 negative. So that gives me a total of 4 negatives. So I need a total of 4 positives. I've got 1 manganese. It's got to be 4 positive. That's the only way it adds up to 0. Because manganese is 4 positive and O is 2 minus. Those 2 O's are going to make it add up to 0. So that must be manganese 4. So that 4 plus the positive charge goes there. Okay? What about FeSO4? Yep, so Fe is a metal, right? So it's ionic. Fe is not in a column I know, so it's going to be iron something. SO4 is sulfate. I promised you when you took the test, the polyatomic ion list was printed on your test. It'll be printed again. You don't have to memorize it. You just have to be able to use it. But we recognize it's polyatomic because there's a total of 3 capital letters there. We only know one way to name things with 3 capital letters. So that would be sulfate. I looked it up. And I looked up sulfate and it's 2 negative. This whole thing is 2 negative, so my whole negative is 2 negative. My whole positive has to be 2 positive, so Fe has to have a 2 plus charge, so this is iron 2 sulfate. It's this charge right here that goes there, and that charge is what makes it equal 0. At 2 positives and 2 negatives, that's going to equal 0. If I try to go, think about what going the other way. If I asked you to write the formula for iron 2 sulfate, you'd say iron, its charge is 2 plus. Sulfate, its charge is 2 minus. That adds up to 0. I'm done. If I went the other way with manganese 4 oxide, I'd say Mn, it's got a 4 plus charge. Oxide, it's got a 2 minus charge. Those don't add up to 0. If I did the crisscross, I get Mn2O4, and that would add up to 0. But for ionic compounds, we want the lowest ratio, so that would be MnO2. So I got to reduce that if I can for ionic compounds. Don't reduce molecular compounds, only reduce ionic compounds. Make sense? Coming back to you. And the reason why I want to do this is because this writing formulas part right here is what cost people on the finishing the equations. When you had to write the stuff on the other side, people weren't using charges to make sure they had the right formulas on the other side. Okay? Talk a little bit about that probably tomorrow. Anything else come to mind? No? Okay. So, papers here with yours on top. Put them in, put them down. Okay, so I'll give you the worksheet. Now, the worksheet actually has 2 sides. I only printed one because you'd done the other side before. But if you look at it on School Loop, if you want to practice those, and you're working on School Loop, if you look at the PDF, it's got the second page with the answers written there. So that you can go back and check, just go back and look and see if you can make those answers show up again. So there's a PDF with worked out ones afterwards. Somebody has taken my stack of papers. It was a big stack too.